Here we have mixed operations with fractions. So you have some addition, some subtraction, and some multiplication. For the addition and subtraction problems, you need to make sure that you have common denominators. But for the multiplication, you do not need to worry about a common denominator. I'm going to do one addition, one subtraction, and one multiplication, and then you will do one of each as well. So here I have 2 times 3 would be 6, plus 1 more is 7. 1 times 6 is 6, plus 5 more makes 11. But these are not common denominators, so I need to change this to match up with a 6. 3 times 2 is 6, and 7 times 2 is 14. 14 plus 11 makes 25. You do not have to change it back to a mixed number for me. The subtraction, we have 5 times 4 is 20, plus 1 more is 21 fourths. 1 times 8 is 8, plus 3 more is 11 eighths. But this is not a common denominator, so I need to multiply. 4 times 2 is 8, and 21 times 2 is 42. 42 minus 11 is 31, so this would be 31 eighths. For the multiplication, we do not need common denominators. 2 times 4 is 8, plus 1 more is 9. 2 times 2 is 4, plus 1 more is 5. 9 times 5 is 45. And 4 times 2 is 8. Please complete the remaining 3 problems, 1 addition, 1 subtraction, and 1 multiplication. So you get to choose the shape of your car. You can think about aerodynamics. You can think about which one looks the coolest, maybe which one looks the heaviest. You decide what characteristics you want to include in your car. I'm going to choose this one. It says you cut off 9/5 of an ounce to make your car. How much does your car weigh? So the original block of wood was 3 2/5. 3 times 5 is 15, plus 2 more makes 17/5. And I cut off 9/5. That's a subtraction. 17 minus 9 would be 8/5, which is 1 3/5. I think we can leave it as a fraction, so I'm going to write it as 8/5. And I got to check, so I was correct. You entered a total weight of 8/5 ounces for your car. Choose wheels for your car. I'm going to go with these. Total set of 5 wheels is 1 ounce, and a set of 3 axles is 3/50 ounces. You entered a weight of 8/5 ounces for your car. How much does each wheel weigh? So I have 1 ounce, but it's for 5 wheels. So if I want to know how much each one weighs, 1 divided by 5, or 1/5, is the weight of each wheel. What is the total weight of your car with 4 wheels and 2 axles? So I have my car was 8/5. Each wheel is 1/5. And I'm going to put 4 wheels on my car, not 5. And 3 axles is 3/50. But I don't need 3, I only need 1. So I can think of that as a multiplication of 1/3. Well, these are going to divide out, so that would give me 1/50, but I need 2 of them for each axle. So let's combine the pieces that already have common denominators. 8, 9, 10, 11, 12/5, plus this is 2/50. But fifths and 50ths do not have a common denominator, or don't have a common denominator yet. So I need to rewrite them using a common denominator. This could be multiplied by 10 to get 50. So this is 120 instead of 12, and 50 instead of 5. Now 120 plus 2 is 122/50. And I have a check mark. Now I could also simplify that. Those are both multiples of 2. So 25 for the bottom. 100 is 50. And if I split 22 in half, that would be 11. So 61/25 would also work here. Let's try that and see if it says that it's correct. Yes. You entered a total weight of 61/25 ounces for your car. Choose the color of your car. I'm going to go with red. 1 can of paint will paint 10 cars. How much weight does the paint add to your car? So 4 1/5, that's 4 times 5 is 20, plus 1 more. 21 fifths. But that paints 10 cars, so we're going to divide by 10 to figure out how much it would be for one car. I can rewrite this as multiplying by 1/10. 21 times 1 is 21. 5 times 10 is 50. What is the total weight of your car with the paint? So we have 61 25ths, or we had 122 50ths, plus this 21 50ths that the paint adds. 122 plus 21 would make 143 out of 50. Yep. Now we need to add some decals. I am going to add a lightning bolt. One decal sticker is 1/25 of an ounce. You entered the total weight as 143 over 50 ounces for your car. How many decal stickers do you want? Remember that your car can't weigh over 6 ounces. Well, 6 times 50 would be 300. So 350ths is my maximum weight. So I can add multiple decals. I'm going to add 2, 1 on each side. What is the total weight of your car with these decal stickers? So I have 143 over 50, plus I'm adding 2 stickers. Remember, they have to have common denominators, so I'm going to rewrite these out of 50. I have to double 25 to get 50, so I need to double the numerator as well. 143 plus 2 is 145, plus 2 more is 147. And we keep the denominator the same. And we check our work before moving on. You entered a total weight of 147 over 50 ounces for your car. How many half-ounce weights should you put on your car? Remember that your car can't weigh over 6 ounces. So I want to probably get close to 6 ounces so that my car is heavy, and then as it's going down the ramp, it's picking up speed. But I don't want to exceed 6 ounces. So I'm going to rewrite 1/2 as an equivalent fraction over 50, so I can easily add them to that weight of my car. 2 times 25 is 50, so 1 times 25 is 25. Remember, we talked about 6 ounces would be 300 over 50. So if I add 1 weight, five plus 7 is 12. 4 plus 2 is 6, plus 1 more is 7. That puts me at 172 over 50. That's for 1 weight. I would like to add a couple more. So 172 over 50. Let's add 2 more. That would be 25 over 50 and 25 over 50. That would put me at 172. 25 and 25 are 50. 5 plus 7 is that 12. So that's 222. And that would be for 1, 2, 3 weights. Let's go with 2 more. That would be 272 over 50. And that's going to put me close to 6 ounces, but not over. Okay, so that was 1, 2, 3, 4, 5 weights. And that puts me at 272 over 50. Yes. All right. You entered a total weight of 272 ounces over 50 for your car. Use the slider to choose the location of your weights. I think having weights either in the center or closer to the front are going to help me, but I'm going to go with the center just for now. On a trial run, your car went 10.5 feet in 78 over 1,000 seconds. What is the speed of your car in feet per second? Okay, so feet per second. That would mean we divide the feet by the seconds. 10 times 2 is 20, plus 1 more is 21 over 2. And we're dividing it by the seconds, which is 78 over 1,000. Now we're going to leave, change, change. 2 and 1,000 have something in common. 1 2 fits into 2, and 500 2s fit into 1,000. Three fits into 21 and 78. It takes 7 3s to make 21. And it would take 26 3s to make 78, I believe. Now we're going to simplify that, or multiply it out in its simplified form. 7 times 5 is 35, so 7 times 500 would be 3,500, and 1 times 26 is 26. So this is, let's clear some of that out so we can see. $3,500 divided by 26. Yes. If we wanted to, we can continue to divide that to create a decimal as an approximation. It goes about 134 feet per second. That doesn't sound quite right. All right, here is a clip of the cars. In class, we are going to have values that match with the cars that you guys create. And so on this slide here, we would have values that would match actual cars that you guys created. It's going to rank the first 3 cars. However, I've only entered data for 1 car. So like I said earlier, it says it will go 134 feet per second. And then we'll have other ranks from other students here with some names that correspond to your classmates and how fast they go. And we're going to discuss what are some common characteristics that created a fast car. We'll discuss, what types of weights you guys added, whether you wanted to get close to 6 ounces or to be very light, what body style of car you chose, whether you chose one that was aerodynamic or one that was a little more boxy, and some features as far as what paint or what wheels you selected that made your car fast. All right, so this is just a lot of work with fractions as far as adding, subtracting, dividing, working with those fractions to figure out weights of the car and some different speeds. Please make sure your warm-up is finished with those 3 extra problems you had to do. And then if you have access to this digital lesson, try it out and see what kind of car you could create and if your car would be faster than the car that I made.